Here's another cartoon of it. Here you can see an area that's been invaded by cheatgrass next to an area that is desirable native bunch grasses, very different fire behavior, very different resistance and resilience in terms of the propensity of this landscape to be stable and staying the same. However, from Landsat or most other satellites, at first blush, first look, these landscapes are relatively indistinct and hard to tell apart. Grass is over here, grass is over here. These two cover types will also be part of one of the most fundamental ways that we map vegetation for wildfire fuels management. So we can map the community types. At one scale, this might all be mapped as a grassland. At a finer scale, this might all be symbolized as annual grassland. This might be symbolized as perennial grassland. We also might map this in terms of fractional cover. This would probably map out as 80% grasses, cheatgrass, and this would map out as maybe 50% perennial grasses, so fractional cover. Or we might map this as, this could be mapped as what's known as a fire behavior fuel model, and this could be mapped as a low load semi-arid grassland. And the code for that for Scott and Bergen's database of FBFMs would be a GR1, grass 1. GR2 would be more fuels, usually for a wetter area with taller stature, denser grasses, and so on and so forth, up to levels 3, 4, and 5. So you could have grasses GR1, shrubs would be SH, and then the combo of grasses and shrubs is GS. So Scott and Bergen give us a library of 40 different FBFMs to pull from. Are those resolute enough? And how can we accurately map them on the ground? This is where tools like LANDFIRE are absolutely critical. LANDFIRE, based off of, most of you know about it already. It is parameterized in part from Landsat imagery. Another source of information that is now slightly more resolute, now down to 10 meters resolution, is the Rangeland Assessment Platform, readily available online. A sister or cousin to RAP is RCMap. This is a USGS project. All of these form the foundation from which we start our scan and inventory of the vegetation and the fuels across the large landscape units that are the management units in the Western United States. So again, huge landscapes, big areas. We can't put boots on the ground everywhere. We've got to rely on these types of tools. LANDFIRE is pretty handy because it's just a deep set of many different data types, links pretty readily with some of the fire models. Is it accurate enough for, off the shelf? Can you just simply grab this and run with it to get accurate mapping of fuels and modeling of fire at the scale at which managers decide which treatment to apply, where and when, and what were the outcomes of that treatments? And the answer is it's imperfect, but the good news is that there are ways to improve it, and those ways are getting better and better literally by the week. It's a super exciting time to be in this line of work. And that's in spite of all of our challenges lately with science and support of land management in the federal government. So FBFMs, how to map them. This is kind of an outline for the talk today. We're going to talk about a set of different large landscape projects. One was the Soda Wildfire. Another deals with national park sites. This is 300,000 acres. This gets up to like 1 million acres. And then we're going to look across many different land ownerships in the Department of Interior, 4 million acres. And then come back around to super high resolution, moving into the Department of Defense, all these major landowners. So first, we're going to focus on the Soda wildfire. This happened in 2015, right here, close to Boise. 300,000 acres burned along the Oregon-Idaho border. This became a focus area and focal project for all things dealing with fire in the Department of Interior. It has since become by far the very best well-studied wildfire anywhere on Earth. There's something like 50 publications now, mostly from our team on this. And so here you can see the range of elevations, lots of ecological variability, and the fine lines in here show all of the different pastures and management units, 105 of them. All the points show 2,000 plots, field plots, that were measured using standard rangeland measuring techniques every year, almost from 2015 to 2020, so the first 5 years after the fire. And then we just finished the 10-year monitoring. Pretty exciting. And initially, the mode of operation by the agency was to try to use remote sensing and a graduate student to monitor the outcomes of what was the most intensive set of herbicide and seeding treatments done to stave off the cheatgrass fire cycle. Here's a graph showing something that we've learned from the accuracy of RAP and RC-MAP. Here's field estimates from these plots. Here's the remotely sensed model of cover based on satellite imagery. And a one-to-one agreement would be shown along the dotted lines. And here you can see for shrubs, in spite of their wide range in abundance, there's a tremendous offset. The model is tuned to much larger scales than 300,000 acres. Even though this is a large landscape, it's still small compared to this sort of model information. And because of that, we get what we call a false modern effect, where the vegetation estimate based on remote sensing tends to underestimate cover when it's most abundant, and conversely overestimate it when it is least abundant. And this is especially bad when you look at things like litter, which matter a lot for fire. Same thing with bare soil. So here we've shown that you've got to be careful and selective and strategic in how you use these kinds of tools. So one of the modes that we operate is with skeptical enthusiasm. So first, a test of assumption on how well these models work. And now with our enthusiasm, we're going to figure out how to still make use of these tools, because the bottom line is we still have to use these tools in spite of our recognition of their strengths and weaknesses. So Jake reconstructed via simulation the 5-day progression of the Soda wildfire. So Jake, the ignition was somewhere right down in here?
Yep, so the star marks the ignition.
And then it passed to the north?
Basically passed straight north the first 2 days, and then that whole chunk turned into a big, huge flanking fire, which then was pushed to the east.